Okay, we have a MacBook Pro. It's a no power, so it says it doesn't turn on. So this is a form factor for the A1502. A1502s were so this form factor Apple had that with the A1425 as well, which is the first Retina that Apple made in the 13 inches, and the A1398 being the first Retina that Apple made as regards the 15 inches. So this form factor here, the A1425 looks exactly like this, but that's a 2012 early 13-ish, early 2013-ish. And this form factor, A1502s will be from 2013, 2014, and 2015. That was discontinued. So let's see what model this is. Okay, this is A1502. So the A1502, it's going to be it's from 2015. Sorry, from 2015 down to 2013. A1425, it's only 2012 and early 2013. So if you see that is A1502, then it's going to be 2013, 2014, or 2015. Now, right from the physical design, there is no way you can tell the difference between 2015 and 2014, 2013. 2013, 2014 will be the same thing. You can change parts between 2013 2014, but 2015 is slightly different. For example, the trackpad of 2015, it's not the same as the 2013 2014. The haptic feedback, for example, that is used on the 2015, that is not the same thing that you find in 2013 2014. One of the ways you can differentiate between if the device is 2013 2014 while the device is off is by clicking on the trackpad. So if the trackpad responds, if you get response from the trackpad, let me show you now. So if you get response from the trackpad, if you get a click like this, I don't know if you can hear that. Now that is the 2013 2014. But if the trackpad is hard, if the trackpad is hard, and then that is a 2015, it will only become active when the device when there is power, the device is in SO state. So that's one of the ways you can, because other than that you will not be able to tell if this is a 20 just by looking at it, or by having to, unless you have to use a serial number to check to confirm if it's a 2013 or 2013 2014 or 2015. So 2013 2014 will be treated as one, while 2015 stands on its own. The screens can be can be used between them, but there's going to be a slight delay in terms of the behavior of a 2015 screen on a 2013 2014 will be slightly different. In any case, so this is coming in for no power. We see that one of the arrow keys are missing, and this is a 2015. And then another thing is, the reason why we say it's 2015 is because of the trackpad. Sometimes you might have a situation of a swollen battery, which then occupies a space, which then forces the trackpad from the other side, and then the trackpad also becomes hard. So that can also be the case. But this one, it doesn't seem like we have a protruding battery, but that we cannot really confirm. But again, sometimes you should be able to confirm from the way it looks on the back. So first thing we're going to do, as always, we want to take out the back cover without having to connect power to it. And all A1502s, they use the Apple MagSafe 2 charger. And the charger for the A1502s are 65 watts. If this is the first time you're doing this, you want to take note of your screws. Okay, so now when you open up the back cover of the device, one of the ways you can confirm that this is indeed a 2015 is the trackpad cable that goes over the battery. So if this was a 2013, 2014, as a matter now here you can see the trackpad, the trackpad design is completely different. Now, if this was a 2013, 2014, the trackpad cable will go underneath the battery. Now, but the 2015, now this same trackpad cable going over the battery, that would be the same thing with the A1398, the 15 inches as well. So if the trackpad goes over the cable, then it's a 2015. If the trackpad goes under, if the trackpad cable goes underneath the battery, it's 2013, 2014, and below, including 2012, A1425. But if the trackpad cable goes over the battery, then that is a 2015. Okay, so we have a couple of capacitors here. We're not sure where that's coming from. We have a screw that is also loose here. So first thing we want to do is to disconnect the battery. We also have, okay, we have that screw missing. Accounting for the trackpad and IO board cable, IO board trackpad cable, as well as the IO board cable is missing. There's supposed to be a shield cover here that is also missing. Okay, so the screw here is missing. The screw here is missing. So first thing we want to do is we want to connect. Okay, yeah. Before we do so, let's see if we have a short on the board. So it's been long since I work on this one. So this is going to be an 820-4924. That's the board number. 820-4924. I hope that's what the board number is. I'm just going to check. So it's 820-4924. Is that what it is? Yes, that's correct. 4924. So that's your 2015. Okay, so and then I'm just going to grab a 2013 board, 2013 and 2014. Show, let me see. Okay, so not that I just so that you can help familiarize yourself, and again, when you are maybe getting parts or when you're working on a machine. Now, the reason why this is important, I'm going to get to that. So this board here, this is a 2013, 2014, correct? Now, if you are to install this here, it's going to fit 100%, with the exception of, so there are going to be a couple of exceptions. For example, this cable, the cable, you will be able to get it, but the trackpad cable, it's not going to fit in. Yeah, so that's number one. Number two is, if you look at the RAM shield, the 2015, the 2013, 2014 do not have RAM shield, correct? Only 2013 and 2014. Now, the reason why it's important, this was one of the first boards that I actually worked on back in 2016, 2017, 20, I don't remember the year, but 2016, 2017-ish is one of the first board that I actually worked on the on this particular design. Now, the way this function is, the fan, it's not always on. The fan only comes on upon request. This fan here is always on. So say for example, if you connect the charger and you're waiting for the fan to spin and you don't have the screen connected, and then you're expecting the behavior that you get from here, which is the fan to always spin, to be the same thing here, you might think you have a problem with the fan, or you might think the device itself is not coming on. So this fan, 2013, 2014s and below, fans are always on. 2015 fans are not always on. Fans are only on upon request. So that's the huge difference. That's something that you need to be aware of, especially when you're troubleshooting this, and the board is out of the shell, and then you plug your charger, and then you're not getting a continuous fan speed. You might think you have a problem. You might think you've not gotten to where you want to be, but understand that the 2015 boards, fans will not always be on. 2013, 2014 boards, the fans will always be on. Now, the BIOS chip that is going to be used on the 2015 also is going to be smaller. So this one, this is a 2015, the BIOS chip. This is the BIOS chip. You see, it's quite big. This is a 2013, 2014. The BIOS chip for 2013, 2014, for 2015 is going to be somewhere around here, and it's going to be smaller. Let me just quickly grab 2015. And so also you can also easily use the board number to identify them. So the 2015 is going to be 4924. The 2015 is going to be 3476. The 2013, 2014, I keep missing them. 2013, 2014 will be of the same board number, which is 3476. However, 2015 will be 4924, which is the board number. So this, for example, you see that the board, the BIOS chip, this is going to be the BIOS chip on the board. So if you see the BIOS chip for 2013, 2014, you see it's quite huge compared to this one. That is the BIOS chip. So this is some of the changes, but other than that, and then another thing is you cannot use SMC of 2015. You cannot. This is SMC. You cannot use SMC here too. You can only use SMC for 2013, 2014. But with this SMC, you cannot transfer it here and expect it to work. You have to reprogram the SMC to work with it. But that's not the case if you're transferring this from a 2013 to a 2014 to a 2014 board. So that's basically some of the differences between the 2013 board and the 2013, 2014, and 2015. Okay, so yeah, pretty much. That's, I think, if there's anything more, I'm going to mention as we go on. Okay, so this is coming here for no bar. The first thing we want to do is we want to see if we have a short on the board. Let's see. Okay, I think I see something already. It looks like there was like a smash here. That doesn't look good. That is the PPDC inline. So that line there, that's the PPDC inline. That resistor that you see there, if we flip the board to the other side, what we just saw now is this guy here. This guy here. So that is R7020. That's the PPDC inline. So if we have a problem there, we might have a situation. So this is the connector. This is the DC jack. Yes, the DC jack connects here. You plug the DC jack. This is the port of the DC jack. Your 20 volt, your charger voltage is going to go through the DC jack and then finds its way through your fuse and then goes, and then you have a Q7010. So if Q7010 is looking that way, we might, okay, first, let's quickly open up the board view. So we say the board view, the schematic board view is already open. So it's H20-4924, 20-4924. So we're looking for the schematic. We have a board view. Something very funny is happening with my schematics, because what happens is I keep struggling to find the schematics. Yeah, this is like the third board that, I mean, I have the schematics. So okay, 3476. Let's see, we can use the same. We can use 3476. 3476. That is the 2414. We can use that. Okay, yeah, let's just use that. So we are going to look for J7000. Say J7000 23. So yeah, this is J7000. So that is going to be your DC jack. That's a DC jack connector, and the resistor that we saw that's not looking okay. It's going to be R7020. This guy here, and R7020 is going to be, that's R7030. Where is your R7020? R7020 is going to be here. So R7020 is going to sit here. So, but R7020 is going to come after this MOSFET here and that MOSFET there. So first thing first, let us see what is it that we're getting. Let's see, do we have a short on the board? PPDC infused, we don't have a short there. PP bus, we don't have a short on PP bus. Okay, so yeah, we don't have a short, we can connect power to it. It's going to use a MagSafe too, so we connect power to it. Okay, that is fine. The fact that we get green light and amber, it means our PPDC inline is okay, because if that was not okay, so that component there is this guy here, R7020. So the fact that we're getting green light and amber, it means that PP3B42 is present, and PP3B42 will not be present if R7020 was not working, because the input voltage for the creation of our PP3B42 is generated from, says it will come from R7020, and this is our PP3B42 PP3B42 supply. So this guy here, now we're getting PP3B42, because if we were not getting PP3B42, if this was not working, we will not be getting this, because U7090 requires this voltage here, which will come from R7020. R7020 goes to a diode, and then it goes to the V in for U7090. The fact that we're getting the green light and amber, it means that we have the R720 is doing its work. Okay, so let's see what we have on PP bus. we are not going to worry about PP342. Why? Because we have LED on our charger. If we didn't have PP342, there will be no LED. So we are going to skip that and just go straight to our PP bus. Now, PP bus, we are going to measure PP bus on resistor here. This guy here, R705. So that's what we are going to measure, 7005. Let's measure our PP bus on that and see what we get. This guy here. 12.6 that is fine because that means that our PP bus, our SMC is actually running. Let's try that again. See what do we have. 12.6 is, yeah, that's fine. And then on the other side, that is fine. So that would almost assume that the device is powering on. So let's connect the battery. Let's have the battery connected and see, do we have feedback on our trackpad? We don't have feedback on our trackpad. Okay, so, and we don't have anything on the screen. Okay, so we have PP volts, we have PP342. Let's see, do we have any voltage on our RAM line, which is GD4? Oh, you heard just now. You're not even sure. Okay, I hope we have sound. Hopefully. Um. Okay, so let's see. We did confirm that that is present. We confirmed that PP bus is present. What do we have on the line to the RAM? Okay, fluctuating. Okay, it's not that it's not present, but it's fluctuating. Okay, we have to take the board out. Okay, so let us take the board out and get to know, understand what is happening and why the device is not starting. You see also with this one, for example, we are not looking to see if the fan is spinning because, like I said, the fan is not always on. And because this is coming from a repair company, I'm very sure that screw is also missing. There's been a previous repair attempt on it. So only when they are unable to get it done will it come here. So that's a wrong screw. It's not supposed to be there, but yeah. Okay, so let's take the board out. Now all the screws out. Yes, all the screws are out. So usually with this ones, I leave the DC jack on the board because I need the DC jack for my troubleshooting. Is that liquid? I don't think so. Okay, so let's put the board on the side. So first thing we are going to do is to perform a visual inspection. So we want to go over the board and see if anything stands out. I mean, when you're working on this board, you want to see if there's anything that stands out before you turn on your brain. So let's see, does anything stand out? Big boss, how are you? Okay, the board is fairly clean, actually exceptionally clean. Uh, um, other than, what's up? What you need? 2012. 2012. F1425. No, this is a 1502. That's 2013 and above. This 2013 and above. 2012 will be F1425. Yeah. Okay, what do you need? Okay, no problem. Okay. look into it. So there seems to be an impact here, and then there seem to be, so two components are missing here. You see those? This, yeah, those components are broken off. So something smashed into. Uh, uh, I'm not sure if those are capacitors. They wouldn't. Then it wouldn't really matter. But if those are resistors, then that would be something. So let's see what those are. Unfortunately, those are capacitors, so they really didn't mean nothing. So these two guys here is uh, yeah, they are C3090, and those are actually for Thunderbolt, so they're not relevant to us current issue. Okay, so let's see what more are we looking at. Mm, 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 mm. Is there anything else? Is there anything else? Is there anything else? Okay, so this with this one we are going to basically go back to the old, not old, to the old method. Okay, not old. So to the troubleshooting process for this one is going to be slightly different from the newer version. So first thing we want to do is we are going to go to page one. So we are going to now go to page one. So because we are going to start from the very beginning. So on page one, we will find where it says power aliases. So that is where we want to go to. We want to go to page 65. That is going to list out all of the power rails of this machine. So 65. Now these are all of the power rails that are present on this machine. So we are now going to go over the power rails one after the other. So first thing we are going to do, some of them we are going to skip because we confirm that they are already present, and then we move our way up. Okay, let's connect our charger. Charger is connected. We have green light and then moves to amber, which is good. So first thing first, we want to see what do we have. Let's see. We did confirm that some of the rails are present. We are not going to repeat those. So yeah, we're going to start. So from the very beginning, we see that PP bus, we need to measure for PP bus. And then it says PP bus is 8.6, correct? That is not correct because 8.6 is going to be for MacBook Air, not a MacBook Pro. So that is supposed to be 12.6. We confirmed that PP bus is already present. We are not going to go back to that. PP bus underscore HS underscore S5, that is present. We are not going to worry about that. That's present. We're not going to worry about that. PPDC in is present because PPDC in is required for PP bus to be created. That is the starting point of your voltage line. PPDC in, we're not going to worry about that. PP3V42 is required for our one wire circuit. The fact that we have PP3V, the fact that we have green light means that PP3V42 is present. We're not going to worry about that. But then we want to check to see if our ROTC line is present. So we're going to copy that and then ROTC. So you see why it says G3H. So that means that rail it's critical and it should always be present. So let's copy that rail and go confirm that the rail is present. So we are going to go to our board view. We copy and then we go paste it on our board view, because now we are now going to search for what is not present, which would then suggest why the device is not powering on. Okay, PPVRTC, that's our clock line. Let's see if that is present. Okay, so we can check for that on C1910, and then that's going to be on the other side of the board. On the other side of the board, C19. So this is the chip here, and C1910. Actually, the board is getting warm, which would suggest that the device is in SO state. Yeah, the board is getting warm. So if that is the case, it would mean that now we should have 5 volt on this line. So let me just go back here. So this guy here, L7520, will have 5 volt there when the device is in SO state. So let's see, do we have 5 volt? Yes, we have 5 volt. So now the device is actually starting. And this guy here, remember we're having less than 1 volt here. Let's see now. and now we're having 1 point something. So it means the device is actually started. So it could be that one of what's connected on the board, one of the cables connected to the board is our problem. So let's put the board back in the shell and start to connect the cables one after the other to see which cable is actually creating problems. So we don't know, maybe it might be a 5-volt line that is shorted through our IO board cable here. So, but then we confirm that now. Let's put the board back in its shell. So that you can either let it slip in or you let it, you can either, so you can either leave it to go in or you just let it sit on top. You understand? Or you can let it, okay, so what we are going to do, first thing we are going to connect, so let's connect all the cables except this one. Trackpad cable connected, keyboard cable connected. Okay, speakers connected. Let's connect the screen. Do we need that cable? That is for keyboard backlight. Okay, let's just connect that as well. Although it's not important to us, let's just have it connected. Do we need the webcam cable? Let's just have it connected as well, even though we don't need it. Okay, so we are going to leave this guys disconnected. Now let's see what we have. So let's connect power to it. Say, let's measure it to see if we still have 5 volt on this guy here. Yes, we have 5 volt. The device should be starting, and yes, it is starting. I'm not sure if you guys can see that. Can you see that? Yeah, so you can see it, yeah? Okay, so what you want to do now is disconnect and now check with this to see if that's a problem. Let's check again. See, do we have 5 volt? Okay, so we most likely have a short on the 5 volt line because of this guy here. So we have a short on a 5 volt line, and so let's so right now you see the device is not starting. We are not getting 5 volt. You see that? We're not getting 5 volt now. That's because the board is it's the board records that there's a short on it. So let's look at that. So that is going to be on this cable here. We have 5 volt, correct? We have PP5 volt underscore S3, and then we have PP3 V3 underscore S4. So I suppose one of this is shorted. That is why it's not starting. So let us see which one of those lines are shorted, because that cable only has two power line to it, correct? 3.3 volt in S4 state and 5 volt in S3 state. So let's see which of them is shorted with that cable connected. So we're going to disconnect that. And then we know that the problem is not on the board, it's on the IO board. So we just want to see which of the line is shorted. And oftentimes when that happens, it's a cap that is basically blown out. So, so let's quickly check that. So let's see which of the line, is it the first one or the second one? So it's a 5 volt line. So 5 volt line is pin 4. That's a 5 volt line. Eh? That's one that is shorted. And if you check the second line, that should be fine. Second line is fine. The two are ground. We're not going to worry about those. So our problem is the first. So that's where the short is. So what we want to quickly do is take that out and see 9 out of 10. It's a cap. 9 out of 10. So let's take that out quickly and see which cap is causing the short. So usually a cap like that, you just need to remove it and you're good to go. Okay, so okay, so let's also remove the Wi-Fi card. Okay, so with the Wi-Fi card removed, let us see if the problem is also from the Wi-Fi card. So how we're going to confirm that is we connect, yes, and then check. So with the Wi-Fi card removed, we are trying to isolate if the problem is on the Wi-Fi card or on the card itself. So Wi-Fi card removed. Let's see if we still have a short on that. Red probe on ground, black probe on ground, and then our red probe. Let's just confirm. Okay, so let's check that line again. Okay, the problem is not on the Wi-Fi card, it's still here. The problem is on this card here. So let us open that, see if anything stands out. Okay, nothing stands out from there. That's fine. Mm, it doesn't look too good, but doesn't look so bad as well. Then on the other side, uh, that also doesn't look too good. So first, let's remove that guy. So we're going to start with that guy. It doesn't look so good. Okay. We are going to read across the capacitor itself. If it beeps, then chances are that that's our problem. If not, we have to keep looking. Okay, that's not our problem. Uh, and then this guy here, let's so that we're just going to do this. We're just going to remove it from the rail. Let's check, see if we still have a short. Then check this inductor here. Okay, let's the cap that we removed here. Do you see it? It's this guy, correct? Let's see. Do we have a short across it? No, we don't seem to have a short across it. Okay, but nonetheless, let's check the board now. Let's see if we have if that's our guy. Okay, we still have a short. So another thing we can do is it's okay. Let's see. Mm, let's check these guys here. We don't want to inject voltage on it. Let's see what else could probably be a problem. It's not a cap. Then what are we looking at? Okay, let's check this inductor here. This guy here, which is a USB line. Let's see. No, we don't have a short on the USB line. Okay, we have a short that side. We don't have a short here. We have a short there. And then this guy's here. We do have a short. And this guy here, do we have a short? No, we don't have a short on this USB and this USB. And this guy. Okay, it's not on ground. Okay, so let's remove these guys because and also I'm just going to remove one just to confirm that I actually have a short on that line, because I'm not sure if I was able to measure the line properly. Okay, I'm just want to confirm that I actually had a short on that line. That's supposed to be ground and that's supposed to be the main line. Okay, yes, I do. We do have a short on that. Okay, so let's remove those capacitors. Okay, caps out. We still have a short on the line. Okay, the short is gone. So one of those guys is our problem. So what we are going to do now is we're going to flip the caps and see which one will beep across it, and that will be our problem. So whichever one beeps, because we know it's definitely not this one, because after we took it out and then we checked. So let's see, is it this guy here? Yeah, that's our problem. So it's not supposed to beep because it's a cap. Both, there should be separation between both, so that's fine, and that's fine. So yeah, so we only have a problem with one. Okay, so let's put back. Again, another one. We can just use something else. So this was the one that showed it, correct?
Yeah.
And also you look at this has orientation, yes. So that marking that will signify pin, the main pin, and the other side will be ground. So when you're replacing them, you make sure that you are aware of what is what. Okay, and then the last. So, so you see those capacitors that have markings to signify pin 1 and pin 2. So those are the ones you refer to as polarized. They have polarities as polarized. And then this is also a cap, for example, but this is not polarized, because this now, it doesn't matter how you turn it, it's still fine. It has no particular pin to say this it's ground only, and then that is the main line. So that's one of the ways. So that's what would mean polarized capacitors as well as non-polarized capacitors. Okay. Um, that's. It seems like the big screw that was here fell, correct?
And yeah, that's
Okay. So okay. Yeah, it is. So we're just gonna clean. Okay. So we can put this back. When I'm putting that screw, I have to be careful because of that. So I want to make sure that that is aligned properly. Okay. Okay. So just want to say they are self-explanatory as to where the cables go, correct? So I'm gonna leave that. I'm just gonna test it now that you say that we now have a board that's working, and then I'll leave you to finalize. Okay, I'm just gonna connect the trackpad, connect that cable, and that as well. Mm, I didn't properly align the board. Okay, yeah. Okay, so and then let's connect the keyboard cable. Let's connect the mic, even though we don't need a mic. But I'm just hoping. I'm kind of putting the mic so that because you see the mic cable is under another cable, so I don't want you to skip that. So I'm just going to connect it for you and then put a speaker. And then we don't need all of that. Do the test. And then the webcam cable as well, don't forget that. You can just put that also in place. It's fine, you can connect the cable still yet. I'm not sure if you guys can see that. So it should be a working device. And then another thing we just want to do is we are going to connect a USB to that side of the board just to be sure that the board itself is working. So I'm just going to switch it to back on, hold the Alt key. Okay, now we have trackpad feedback, which is because the device is in SL state. I'm holding my Alt key. It's the key is not working. Anyways, okay, another thing we can do is we can use the HDMI. HDMI is also on that board. So let's see. Again, forever to boot. Hmm. That's taking forever to boot. Sometimes when the device is taking that long, you want to do a PM reset, and that will be a combination of Alt, Command, P, and R. You switch the device off, switch it back on, hold its four keys combination, and then you start the device, and that will reset the device. Well, this is the final testings are going to be done, but as you guys can see, the device power is on with the cable, the iBoard cable in place, and yeah, that's about it. Okay, I think it's switching. Yeah, it is switching. You see the changes of the display. Yeah, it is. So it's recognized that it has been connected. So it's just so that we can do later. Did you see that? So that's it. Okay, so the board is working. Thank you guys. I will see you guys in the next one.